Hey guys, my name is Tania and welcome back to eCoreAcademy. I'm back with the first lesson of our third chapter for our Algebra 1 course. So this chapter is going to be focusing on linear equations, and this lesson is going to be the introduction to slope-intercept form. We'll be covering several forms of linear equations and graphing them. So this is just the start. In this video, like I said, we're going to be giving you the introduction for the slope-intercept form, but we're also going to kind of drill in what it means for an equation to be linear, for a graph to be linear, as that is the main point of this whole entire chapter, and it is a main idea. And I do want to say beforehand that this lesson is quite different just because it's going to be primarily note-based. We're not going to have any extra practice or anything, just maybe examples that correspond with the notes. But look forward to applying all of this into our next video. We'll be learning more and we'll be practicing more with math problems and stuff. So before we get started, I'd really appreciate it if you guys could like this video, comment down below, and subscribe to our channel. And also, do not forget to turn on the post notification bell on so you guys are notified every time that we post a new lesson that you guys can learn. So without further ado, let's get into today's lesson. So you may be wondering, what even is linear? Well, I'm sure you know that linear means, when you think of linear, you think of line. That's what I've always thought of. But if you didn't, this is a great trick. Well, the definition of linear is just like, or linear equation is just that it's any equation in the form of y equals mx plus b, which is a slope-intercept formula, which is what we are going to be using. The in the form of y equals a number, x equals a number, ax plus by equals c, which is a standard form, which is another form we will be covering later on, and y subscript 2 minus y subscript 1 equals m times x subscript 2 minus x subscript 1. Tongue twister there, which is the point slope form, and that is also one that we will be covering in this unit, chapter, whatever you want to call it. The main characteristic of a linear equation is basically that anything linear will make a straight line. Like I said before, when you think of linear, just think of line. A line is always going to be straight, or it won't be a line. It'll be a curve or anything else, but linear equation is always going to produce a linear line. And that is what you'll see when we are graphing stuff, when we are going to analyze graphs and we're going to analyze equations. Linear equations will not have, linear equations or graphs will not have curved lines, exponents, absolute values, square, cube, or any roots, and we will not be dividing by a variable when it comes to linear equations. Some examples of linear equations will be, or are, y equals x, which is the parent function graph, y equals 1/2 x, y equals x minus 1, y equals 3x minus 9, x equals 5, 5x equals 3y minus 2, y minus 3 equals 2 times x minus 3. As you can see, these examples over here correspond with the equations and formulas that are over here, as they are all linear. Excuse me. All right, so the one that we're going to be focusing on in this video is the slope-intercept form formula. It is y equals mx plus b. So all of these variables in this equation, in this literal equation, has different meanings. It has things that they stand for. So the y in this case is the range, is the output, and it is the dependent variable. The m is the slope, the x is a domain input and the independent variable, and b is the y-intercept where x equals 0. The parent graph and the parent function of y equals mx plus b is y equals x. A parent function just represents a family of functions because it is the most simplest form. So in this case, y equals x represents the family of linear functions. And you did see in the previous example that y equals x is an example of a linear equation. Well, it is also the most simplest form of the whole family of linear equations and functions. So we're going to actually focus on two variables in this video, the story of M and the story of B. Those two are the ones that are what you will be using so much to graph, and it tells you so much about the graph itself, speaking from an equations perspective. All right, so basically, the M can tell you two things: whether or not it's going to be a positive slope or a negative slope, and it can also tell you whether or not the slope will be shallow or steep. So it'll give you two different characteristics. So if the M value is positive, that means the slope is a positive slope. So for example, where in the equation y equals 2x plus 1, the M value in that equation is going to be 2. The 2 is positive since it is above 0. And so basically the graph of that equation will have a positive slope. A positive slope looks most commonly like this. When it is from left to right, it's going up. And also the right side of the line is on the top right. Or it's approaching the top right is the best way to put it. Then there's also the opposite of that, which is the negative slope. So if the M value is a negative number, a number that is below 0, then the slope will be negative. And for example, in the equation y equals negative 5x minus 5, the M value is negative 5. Because the M value is negative 5, the slope will be negative. And because the slope is negative, the direction that the slope goes from left to right is different than it did when it was positive. So in a negative slope, the right side will actually, the right side of the line will actually be approaching the bottom right of the coordinate plane. Also, what else the M tells you is whether or not whether the slope is shallow or steep. Okay, so when a slope is shallow, you'll know that if the absolute value of M is between 0 and 1. Keep in mind that M cannot equal 0 or 1 for it to be shallow. It will have to be a number between 0 and 1. So, for example, in the equation y equals negative 1/4 x plus 2, the slope in that, or the M value in that equation, is negative 1/4. Negative 1/4, remember, we are trying to get the absolute value of the slope value of the M value. So it will be 1/4, and 1/4 is between 0 and 1. So therefore, the slope of that equation will be a shallow slope. When we're talking about shallow slope, it kind of just means that it's closer to the x-axis. It's kind of on the lower end. Here is, it's just a little bit down, so it's a little bit shallow. That's how I think of it. I don't know if that makes sense to everybody, but yeah. And then the opposite of that will be the steep slope. The steep slope is when the absolute value of M is greater than 1. Again, it's not equal to 1, but it's greater than 1. And so in the example equation of y equals 8x, the slope is 8. And it's a positive 8. But regardless, the absolute value of 8 is 8. And since 8 is more than 1, not equal to 1, but more than 1, it will be a steep slope. When it's steep, it's a little bit higher, where I think we all know what that means. So here is an example of a steep slope. It's just a little bit more closer to the y-axis. But again, it's not vertical. It has a slope to it. It has a slant to it. And that is what the M can tell you. There's also more. It can tell you whether or not a graph is horizontal or vertical. This can't necessarily, so for starters, a horizontal graph, again, just like this, is when M equals 0. So you know that M equals 0 when it's an equation such as y equals a number. In that case, M equals 0, and since M is multiplied by x, the x times m equals 0, so there's no x either. There's no x value. So what the equation will essentially just be y equals a number, and then you know that that equation's graph is a horizontal line. And so here's an example of that over here. But then the opposite of that is the vertical graph. That is where the m is undefined. There is no value for when the m is undefined. And when you think of the m being undefined, or when there's a vertical graph, just know that the equation that corresponds to that will always just be x equals a number. Here I have written, if I can walk on it, it is a slope. And the way that you think about this is, if a line is horizontal, I can walk on it. Even if a line is steep, I can climb it somehow, I can still walk on it. But if a line is like this, I will not be able to walk on it. And because I can't walk on it, it's not a slope. Therefore, the best way to kind of remember that, a trick that you guys can use to remember that a vertical graph has no slope, aka the slope is undefined, is simply because you cannot walk on that graph. That's just a fun little trick that you guys can use to remember that. But that's the main idea of exactly what the M is and what it stands for. And we'll learn so much more about how to exactly graph these different things. So stay tuned for all that. But then there's the other variable, the story of B. When I think of B, I think of y-intercept, because it determines where the graph crosses the y-axis, which will be when x equals 0, otherwise known as the y-intercept. Also, it determines if the y-intercept is above or below the origin. And you know that because if the y-intercept is above the origin, the b value, which is the y-intercept, will be more than 0, which means it's a positive number. So if the b value is a positive number, the y-intercept will be above the origin. If the b value is below 0 and it's a negative number, then it will be below the origin. But if the b value is 0, then it'll just cross through the origin. So it can quite literally just cross through this point right here. I did have to say that, again, these equations are not corresponding to the graphs over here. Just wanted to give you guys different visual representations. But in this picture over here, you can see that the y-intercept is positive. And so the equation of this graph must have a positive b value. Over here, the equation of this graph must have a negative b value, as the y-intercept is below the origin, which is 0, 0. But this was just like a quick introduction to y equals mx plus b, what exactly m and b are, as those are the two variables that you will be using or that will be helping you so much when you are graphing those equations. But that was it. That was it for the video. Like I said, it was very much primarily note-based. It is different than the other ones, but there will be much more practice that is coming. But I did want to give an introduction to this, as it is probably a brand new idea. I hope you guys enjoyed this video. I hope you guys learned a lot more about y equals mx plus b, its significance, what exactly linear equations are. We're going to be talking about that for a while now. So if you guys have any questions, don't forget to leave them down below in the comment section. Also, here is our website link if you guys want more practice on other lessons. Our email if you want to contact us, and our other social platforms if you guys want to stay updated on eCore. But other than that, I hope you guys enjoyed this video. Again, please don't forget to give this video a huge thumbs up, comment down below, and subscribe to our channel. And I'll see you guys in our next lesson. Have a great day or night, guys.